Do you know the yo? Because we do. Welcome to Yo-Yo Dynamics.
We started by drawing the free body diagram and the mass acceleration diagram. As you can see, you have the force of gravity through the center, as well as the force of tension from the string on the outside of the inner spool. And you can see that the object will be rotating counterclockwise due to this tension in the mass acceleration diagram.
Here we'll begin with our start and our end diagrams. We can see at this, it initially starts at rest, and our velocity and our omega are both initially 0. Now going down to our end diagram, where our t equals time 1, when the yo-yo is at the bottom of its string, we can tell that its velocity is also 0, but it now has an omega.
If you know the time of how long it took to fall, you can then use impulse momentum to see how much of an impulse the tension caused over that period of time to ultimately solve for the final omega.
Now, if you didn't have the time it takes, you could use work energy, using the basic work energy equation where your kinetic initial is 0 and your potential final is also 0. Here, we can just plug in all the equations for each value, and since V2 is 0, this term would go away. Now, because of the equation for arc length, we can substitute in for r theta, the length of the string. Coming out to the final equation, using the length of the string, you could solve for omega 2.
If you're curious to find the motion of point B on the yo-yo, you could use a relative motion equation using the velocity of B, the velocity of G, the center of gravity, and then the velocity of B relative to G. You then know that B is moving in something else, the center of the yo-yo is moving in a straight line, and B is moving in a circle about G. And you break that down to get a final equation.
Now you too know the yo. Go tell your friends.